Hello and welcome to this video. In the previous video we have studied the concept of basic representation in number theory, and in this video we will solve some exercises related to basic representation theorem. Okay, we start with the first question. The question 1 is that let x is equal to 10723, and we have to write x to the base 2. Okay, we start using deepen algorithm. This is solution. Okay, using deepen algorithm, 10723 can be written as 5361 into 2 plus 1, and also this 5361 can be written as 2680 into 2 plus 1 by deepen algorithm, and similarly this 2680 can be written as 1340 into 2, and this 1340 is equal to 670 times 2, and this 670 by using deepen algorithm is 335 times 2, and then this 335 can be written as 167 into 2 plus 1. We will continue this until we will reach at the stage when we cannot do further deepen algorithm, okay, or we do not need to do the further deepen algorithm, and this 83 can be written as 41 times 2 plus 1 using deepen algorithm, and this 41 is 20 times 2 plus 1, and this 20 can be written as 10 times 2, and this 10 is 5 times 2, and this 5 is equal to 2 times 2 plus 1. Okay, now we substitute the value of 5361 from this equation. This is 2 times 2680 into 2 plus 1 plus 1, this one. Okay, and that is 2680 into 2 square plus, when this 2 will be multiplied with this 1, we will get 2 to raise power 1 plus 1. Now the value of 2680 can be replaced here. Okay, we will get 1340 2 to raise power 3, because this 2 will be multiplied with this 2 square. Okay, 2 to raise power 1 plus 1, and now replace the value of 1340. We will get this expression, 2 to raise power 4 plus 2 to raise power 1 plus so on, and now 670 can be replaced with 335 into 2, and we will get 2 to raise power 5 plus 2 1 plus 1, and similarly we will continue in this way until we will reach the situation, and that is actually 2 to raise power 6 plus 1, which is 2 to raise power 5. Okay, I will write here 2 to raise power 5, and the value of 335 is 167 times 2 plus 1 plus 2 to raise power 1 plus 1. Okay, we will multiply this 2 to raise power 5 with this one and this one, so we will get this situation plus 2 1 plus 1 and so on until we will arrive the situation 2 to the raised power 13 plus 2 11 plus 2 8 plus 2 7 plus 2 6 plus 2 to the raised power 5 plus 2 to the raised power 1 and plus 2 to the raised power 0 instead of this one. Okay. Now 10723 to the base 2 can be written as 1 because the coefficient of 2 to the raised power 13 is 1, and here the coefficient of 2 to the raised power 12 is 0 because that term is not here appearing, and the coefficient of 2 to the raised power 11 is 1. Then 2 to the raised power 10 and 2 to the raised power 9 is also 0, the coefficient is 0. 2 to the raised power 8 has coefficient 1, similarly for 2 to the raised power 7, 2 to the raised power 6 and 2 to the raised power 5. But we can see that there is the coefficient is 0 for 2 to the raised power 4, 2 to the raised power 3 and 2 to the raised power 2. So we have 3 zeros. Then 2 to the raised power 1 has 1 and 2 to the raised power 0 has 1. So this is the representation of given number with base 2. We move to the next question, that is question number 2. Okay. Let x is equal to 10723 and we have to write this to base 3. We will proceed in the similar way. 10723 can be written as 3574 into 3 plus 1 using division algorithm, and then 3574 can be written as 1191 into 3 plus 1, and 1191 is equal to 397 times 3, and 397 is 132 times 3 plus 1, and 132 is equal to 44 times 3, then 44 can be written as 14 into 3 plus 2, and then 14 can be written as 4 into 3 plus 2, and this 4 can be written as 1 into 3 plus 1. So here we will replace the value of 3574. It will be plus 1, this one. Okay. And we will get 1191 into 3 square plus 3 to the raised power 1 plus 1. And now we will replace the value of 1191 from this expression. We will get 397 into 3 cube plus 3 1 plus 1, and the value of 397 can be replaced with this expression. We will get 3 cube into 132 times 3 plus 1, and the remaining this expression will be as it is. Okay, so this is 132 times 3 to the raised power 4 plus 3 cube plus 3 1 plus 1, and that will be equal to 44 times 3 to the raised power 5 plus 3 cube plus 3 1 plus 1, and 44 can be replaced with 14 into 3 plus 2, and that will be 3 to the raised power 5 into 14 into 3 plus 2 plus 3 cube plus 3 1 plus 1, and in the same way we will arrive at the situation 3 to the raised power 8 plus 3 to the raised power 7 plus 2 times 3 to the power 6 plus 2 times 3 to the power 5 plus 3 cube plus 3 1 plus 1. We can see that the coefficient must be less than 3 as we have seen in the representation theorem. Okay, so the representation of 10723 to the base 3 is equal to the coefficient of 3 to the power 8 is 1, 3 to the power 7 is 1, 3 to the power 6 is 2, 3 to the power 5 is 2, 3 to the power 4 is 0, and 3 to the power 3 is 1. 3 square is 0, 1 and 1. So this is the representation of 10723 to the base 3. That's all about this video. In the next video we will solve some other examples related to basic representation theorem.